Listen. Okay. So, very good morning to all. Welcome to all for on the third day of the GAN course. So, this is the very first lecture of third day. That is from 9 to 10 a.m. on the third day. And in this, we will take a lecture on the heat wave. Means what is the condition of heat wave on a global level across India, and then finally across Madhya Pradesh. And we have a case study there. We have discussed the heat wave, the number of heat wave events, or we can say the frequency of heat wave. Then we discussed what is the heat stress, and across 7 smart cities of Madhya Pradesh that you know, like Bhopal, Indore, Satna, Jabalpur and all. So we will discuss one by one, and importantly we will discuss how to compute the heat wave. What is the important parameter or data sets you need, and after that how you can compute the heat stress. So in this we have computed 2 different indices which will indicate that how heat wave is affecting us. If that there are different classification of that heat indices, that if this heat indices is ranging from this to this value, how much discomfort will give to us. So because we know that whenever heat wave is there, it is directly affecting us. So if this much value of this particular index is available, then how much discomfort will be there for a human being or any livestock. So before going deep into the heat waves, let's discuss what is heat wave and why we need to understand the heat wave. What is the necessity of heat wave? So if we talk about the heat waves, we have lot of news regarding the heat waves across global as well as from the India. So this is the report across India itself, that some of the study warns against oppressive heat waves due to global warmings. Means we have lot of heat waves across India, and their association with human beings, human mortality in India is shared with these things. Second, if we talk about the hilly areas itself, we usually go to hilly areas in summer so that we can have less effect of heat waves. Usually, for example, right now we don't want to visit Jodhpur or Jaisalmer in Rajasthan. Rather than we will go to the hilly areas, mountainous areas, where we can go for some cold areas we can go. But right now, some of the study, even in 2025 itself, in March 1, they have suggested that our hills are also getting hot. One study has been carried out in Tamil Nadu hill station, and they warns about the heat waves across that part also. Mostly if we talk about heat wave in India in 2025 itself, India is going to experience above average temperature from March to May. And I think you can feel that, no need to explain this thing. Yesterday itself you can see that what is the temperature across Bhopal itself. Even I think before 5-7 days we have some rainfall. Despite of that itself, the temperature is very high, and we are feeling the temperature above than the average temperature across Bhopal itself. And even I think you can feel that even though in the March itself the temperature is very high, because we feel that mid-March is not a very high temperature condition in India, but in this March itself, in the around 15th March, we are facing high temperature conditions. So this report always shows that, and in March 1 itself it is expected that India is going to experience above average temperature in March, April and May in 2025, and we are experiencing the same thing in March, April and May itself. Also these heat waves are also affecting the crops itself. Along with the human beings, it is also affecting the agricultural productions. So if we want to know what is heat wave and how it is affecting us, so this is the report which is given by World Meteorological Organization, and it says the heat wave can be defined as a period where local excess heat accumulates over a sequence of unusual hot days and night. So if we want to visualize the effect of heat wave, you can see that in 2022 a heat wave in China lasted over 70 days. making it the country's worst on the record. You can experience that if a heat wave persists for 2-3 days, it is affecting too much, and if it is going to be last for 70 days, you can visualize the impact of that heat wave for 70 days in that particular area. Similarly, if we talk about India itself, devastating heat waves in India and Pakistan in 2022 were made 30 times more likely due to climate change. Means what is the probability of the heat waves, but due to climate change it is increased by 30 times. So this is the effect of heat waves across India. So these are some of the information. Then let's discuss how we can detect the heat waves. What is the importance, means what is the input variable which is required to compute the heat wave, and how we can declare whether today we have heat wave or not. So there are some classification or definition which is given by India Meteorological Department. So one second, I'll share the YouTube links so that the online participants can also get that. Talk about the heat wave, there are classification given by the IMD, as well as along with the IMD there are some other classification based on the percentile. I think you know how to calculate the percentile. Means you have a data sets, because percentile and percent are two different things. If I am talking about 95 percentile, please don't confuse with 95%. 95 percentile and percent is completely different thing. So there are some definition which are based on percentile. For example, if we calculate the extreme precipitation, usually we take 95 percentile or 99 percentile to calculate the extreme precipitation based on different literature and based on different geographical condition itself. Similarly goes with the heat waves also. In the heat waves we have the classification based on the IMD, which is completely based on the temperature condition. Means we have to take the average, and based on that we can go for that. For example, here itself we have shown that if the temperature, normal maximum temperature is more than 40 degree or above, then from that average, if the temperature is more than 4 or 5 degree, means the temperature is deviated 4 or 5 degree more than the average temperature of that particular area. For example, in Bhopal, if we have 41 degree average temperature and today we have 46 degree, then and this condition persists for 2 days continuously, then we declare that that particular 2 days are considered as a heat waves. That event is declared as heat wave. Similarly, if the temperature conditions are not very high for that particular area, for example some hilly areas is there, so if it is not a normal area or it's a hilly area where temperature doesn't go beyond 40 degree, then the classification that if it is less than 40 degree, for example 38 degree, then we need to increase that temperature for that particular day by 5 to 6 degree. For example, if it is 38 degree, it must be 33 or 34 degree to 43 or 44 degree to declare heat wave event for that particular area, and minimum 2 days should be required. Some of the definition says 3 days are required, some of the definition says 2 days are required. So based on the literature you can go with that. So if we talk about the heat wave events across different parts of globe, so this is a global scenario where we have discussed what is the condition of heat wave across across globe. So we found that there is increasing the frequency and intensity of heat waves across on a global level. So these heat waves are increasing more and they are more severe due to global warming and climate change, and they have high impact on human health or public health and economy. In 2022 itself, Europe experienced record-breaking heat waves causing thousands of deaths and severe economic losses due to heat waves. Similarly, if we talk about the projections or means the future forecasting of the heat waves across globe, by 2050 heat waves are expected to last longer and affect almost every region of the world. Means we cannot say that some of the regions across global are not affected by the heat waves. By 2050 almost every region of the world will be going to be affected by the heat waves. So this is the data set I have taken from the NASA Earth Observatory, and this is shown for the June 2024 of 24 June, and you can see the temperature condition across India itself. We are not ranging below 25, we are ranging above 30 or more than 40 degree itself. So this is the heat temperature condition across India itself. If we talk about the Indian scenario itself, the same pattern or same trend is also observed in India itself. We have rising temperature, so India is witnessing the increase in the frequency of heat waves across few decades. Last 2-3 decades, we are facing the heat waves very frequently, and it is also affecting the public health. In summer 2024 itself, the country recorded more than 40,000 heat stroke cases across India. However, some of countries in the India are planning to mitigate the heat wave conditions. So cities like Ahmedabad also implemented early warning system so that they can give a warning to their residents of the states that heat waves going to be happen in particular days, so that they have implemented the early warning system. Also they have heat action plans to mitigate the impact of heat wave condition across India. So this we have taken from the Indian Meteorological Department only. Then let's go for the Madhya Pradesh itself, because the study is done for the Madhya Pradesh only. So if we talk about this is the report by the Indian Meteorological Department in 2022 itself, and they declared that heat waves between only around 40-50 days have impacted 15 Indian states and UTs across India. So you can see that out of 40 days, Madhya Pradesh is 40 or 50 days, Madhya Pradesh is facing number of heat waves during 25 days. Same case with the Rajasthan, Himachal. Even we know that some of the area are relatively cooler as compared to Rajasthan. However, there are heat wave conditions. It means we can say that the cooler or hilly areas which are relatively having less temperature conditions, also they are facing the heat wave conditions across these last 5-7 years itself. So this is the vulnerability itself. So we can say this Madhya Pradesh faces extreme summer heat, with heat waves intensifying in recent years, especially in 2022 and 23 itself. And the reason behind this is the urbanization effect, because we are creating the cities into the urban heat island effects. So that is the reason, because we are not having green infrastructure, we don't have any cooling techniques, even though we are using the number of ACs, number of vehicles to create the emissions, due to which temperature have high increase in the summer condition itself. So this is the right time that we can take the action for this, and we can do the projection of the heat wave across different parts, and accordingly we have to mitigate, or we have to develop the heat action plans for the cities or the states itself. So this is the case study across Madhya Pradesh, and this study has been carried out by my master student Himanshu Jharia in his master thesis itself. So I acknowledge him for this study. This is heat waves across smart cities of the Madhya Pradesh. So if we talk about India itself, I think I have discussed this. So this is the objective of the study. So what we done in this, initially whenever we have, I think already in last class I told that whenever you are going to take some data from any source, just try to visualize that thing. Means if you are downloading the precipitation data or temperature data set or soil moisture data set, please don't go directly for the use, because sometimes you have done some mistake during the conversion of the data set from some netcdf file to Excel file or some from other sources, and you will going to use directly. So without visualization of that particular data set, you will not able to get the problem or whatever the issue with this. For example, if you are downloading the precipitation data set and you are getting the precipitation high in Rajasthan and less in northeast or western Ghats, so maybe there is some mistake, and obviously there should be mistake in that particular thing. So initially whenever you downloaded the data, just visualize on the map itself, so that you can get average data sets. Maybe for example, if you are getting highest rainfall in northeast or western Ghat and very less in the Rajasthan, it means you can say yes, the process is maybe right, that we have downloaded the data and we have regraded the data set, or we have processed the data set in a better way. So in this we have computed the heat waves, and then finally we have assessed the heat stress and thermal indices. So in this we have used two indices to find out whether what is the heat stress across different smart cities of Madhya Pradesh. So here we have used two index. The first one is the humidity index, that consists of less number of parameters, and the second one is a universal thermal climate index, which incorporates more number of input variables, so that it will give better idea about the stress itself. So I'll tell you what is the formula for both of them and how we have done this. And here we have computed the heat waves based on the two methods. The first method is given by the IMD, that is India Meteorological Department, based on the temperature condition, and the second one is based on the percentile method itself. So this is the study area. We have taken 7 major cities or smart cities of Madhya Pradesh, that is Bhopal, Indore, Jabalpur, Gwalior, Ujjain, Sagar and Satna. And we have taken these smart cities because right now government is giving lot of fund to the smart cities. So we should have a better idea about the smart cities itself, because in the cities itself people are growing very fastly due to urbanization itself. So we have high temperature condition in the city itself rather than the rural conditions. So we must have some mitigation plan for the smart cities or the cities rather than the rural areas initially. Cities? Yeah, it is available, I think so. Yeah, I'll share with you. If you need throughout the India itself, we will share. Otherwise, if you need, yeah, I will share it. Himanshu, please share with them, so that from that link you can get the shape file of any city itself. Okay, then these are some of the data used in this study. So initially we have taken the temperature from the India Meteorological Department. However, the resolution of this data set is 1 degree by 1 degree. So it is regraded to 0.25 degree by 0.25 degree using the inverse distance weighing method that I think you know, that is IDW method. Or the simple way you can do with the bilinear interpolation also. But the problem I suggest you, because this is the most reliable data set as far as IMD is concerned, but more than that you can also go with some other data set which is going to provide the data at a resolution of 0.25 degree, because 0.25 degree is far better as compared to 1 degree. But however, since this is observed data set by the India Meteorological Department, so because of that we have to take that. Otherwise you can take the other data sets which are providing the data set at 0.25 degree, because it have high resolution. Otherwise, whatever you are doing, that 1 degree you are converting to 0.25 degree, and on a very smaller study area it can have maybe less better result as compared to the broader area. Then in this we have also downloaded the relative humidity and wind speed data set. Relative humidity you can directly take from the NCP or NCAR reanalysis data set, that is National Center for Environmental Protection, or NCAR reanalysis data set. Wind speed is taken directly from the Princeton University, and these are also available at 0.5 degree, so we have regraded to 0.25 degree. Then we need air temperature and mean radiant temperature, and all these are related whenever we are calculating the indices itself. Otherwise, for heat wave itself you need only the temperature data set. Other than that you need not to have. So let's discuss what is the methodology in this. What is the process, then how we can calculate the heat wave and thermal indices. So initially we have selected the study area, and based on that we have taken the daily maximum temperature. Means we have minimum temperature from IMD, we have maximum temperature from IMD, but for calculation of heat waves you must have Tmax, maximum temperature condition itself. Please don't take the average of that. Sometimes students takes Tmax plus Tmin by 2. So that is the average temperature. Average temperature doesn't make sense to calculate the heat wave. You have to take the maximum temperature for that. And mostly we know that we usually feel the heat waves only in the 4 months, that is from April, May, June and July. Even the literature suggests the same, that whenever you are going to calculate heat wave minimum across India itself, the condition persists of heat waves only in these 4 months, that is April, May, June and July. So in this heat wave identification, there are two ways to calculate the heat wave. The first one is as per the IMD criteria, in which there are two conditions. If the average of that particular area is above 40 degree, for example Rajasthan or Madhya Pradesh, the average temperature is above 40 degree, then this classification should be used, that day maximum temperature should be 5 degree or 6 degree more than the average temperature. For example, Bhopal is having average temperature of 42 degree, so heat wave will be declared only if the temperature for 2 days is 47 or more than that, like 48 or 47, 49 or more than that. And it should be minimum for minimum continuous 2 days. If today is 47, tomorrow is 47 or 48, minimum 5 degree or 6 degree or more than that. So we have to initially, for example, if we are calculating the heat wave for 7 grid points of particular area, so what you have to do, you have to find out the average average temperature of that particular area. If it comes out above the 40, then you have to use this one, that the daily Tmax should be greater than 5 or more than that, then it is heat wave. And if it is going above 7, then it is a severe heat wave condition, that is more harmful for us rather than simple heat waves. So this is the two classification for the normal areas. If relatively it is a cooler area where the temperature, average temperature never goes above 40 degree, like it is ranging from 35 to 40 itself, then the heat wave is declared then when the daily Tmax is more than 4 degree or 5 degree from the average of that. Maybe average temperature condition is 37 only, so the heat wave should be declared at 41 degree or above than that. Or if you want to declare the severe heat wave for that particular area, it should be 6 degree more or more than that, then it is a severe heat wave. So this is the two classification, because the same classification you can't use for the hilly areas or cooler areas, because it will not go beyond the 40 degree as an average temperature condition. So these are the two classification as per the IMD itself, and most of the literature will use this. Some of the literature will say that you can take 3 days as a consecutive, some of them says 2 days as a consecutive. But from the literature I found that majority of the paper are taking 2 days to declare the heat wave. So we have taken 2 days consecutive to declare the heat wave. If the second day also obeys this condition, then the second day, from second day itself we say yes, this is a heat wave condition for that. This is given by IMD only, we are not deciding. IMD have decided based on the different experiments or different IPCC reports itself. So we are blindly following that only, because this is IMD itself. But since we need to compare whether this is correct or not, so we have done the second method itself, which is based on the percentile itself. So we have taken the data sets and we have calculated the percentile. So for example, for a city itself you have 7 grid points or 5 grid points, you just take out the percentile data set, percentile of that. So I think you know how to calculate the percentile. Simply you have the data set and you can fit the data set into different distributions, that like normal distribution, gamma distribution, Pibul, exponential, different distributions we can fit, and based on that we can find out the best distribution, and that ECDF value we can get it from that, and ECDF value will give you the percentile value of that. So we have calculated the percentile. So literature suggests some of the places using 85 percentile, some of them using 90th percentile to declare whether a heat wave is there, or 95th percentile whether a heat wave is there or not. So in this we have calculated 95, 90 and 85th, and then we have compared which one is more aligning with the IMD definition. So we found that 95th percentile results and IMD results are very close to each other, or the value are very close to each other. So we suggested that if you are going to do that, it's better you can go with the IMD and you can go with the 95th percentile to calculate the heat wave across India itself. In this we also calculated these two values, that is cumulative accidents and absolute accidents, so that we can get better idea about the heat wave condition across different part of the study area. So if we calculate cumulative it is the sum of maximum temperature condition which is exceeding our multiple days. Exceedance means from the average how much it is exceeding. So for example, if it is exceeding 3 degree, so that will be 3 degree for that particular event, then 3 degree, then 3 degree, then 2 degree, how much it is exceeding from the normal condition itself. And the maximum of all the days, for example, heat wave persists for 4 days, how much exceedance at maximum for 4 days. For example, for the very first day it is exceeding 2 degree, then 2.5, then 2 degree, and then 3 degree. So maximum is 3 degree. So this is the exact methodology for the percentile, and this is for the IMD. Then we will compare both of them. Based on that, we will calculate the heat stress. So the first variable we have used to find out the heat stress is humidity index, in which we will take the vapor pressure as the input, and the formula for this is this one. Humidity index is temperature plus 5 by 9, water vapor pressure minus 10. And second, since it is taking only very less input variables, so the second one is giving more idea about the thermal stress or heat stress across due to heat wave itself. So it is taking more variables like air temperature, mean radiant temperature, or vapor pressure. So we will calculate both, and we will look out which one is giving better idea about the heat stress. So how we can get to know that if the value of heat stress or humidity index or UTCI is ranging from one to another part, how we can define whether it is harmful for us or not. So if we talk about HD, that is humidity index, if it is ranging below 29, there is no discomfort for us. So what we are expecting during the temperature condition, the HD should be below 29, so no discomfort will be there. If it is ranging from 30 to 39, there should be some discomfort to us. If it is ranging from 40 to 45, great discomfort, so we have to avoid that thing. And if more than 45, it is very dangerous, it will cause heat stroke and possibly, or it can cause heat death. And if we talk, E is vapor pressure. So if we talk about UTCI, then this is the classification that if it is ranging from 9 to 26, then it is no thermal heat stress, so we are expecting that value for us. And if it is going from 32 to 38, it is causing strong heat stress, then very strong heat stress. And if it is going above 46, then it is causing extreme heat stress, and we need to protect ourselves from these two conditions. But since this is not in our hands, we can go for some adaptation or mitigation. We can't stop that situation, because right now itself, from the morning itself at 9, we are using the AC, so it's not possible that we can stop the heat wave condition or a temperature condition for us. So initially I have noted the temperature data sets only. It is not very important, because we have just shown how the temperature condition is going to be persist for different different cities of Madhya Pradesh. So we have shown that, and the goal is to just visualize the trends of Tmax across different parts of the Madhya Pradesh cities. So these are the classification, these are the figures for the comparison of IMD and percentile method. You can see the first one, the first red line is showing the IMD data sets, means the classification based on the IMD definition. These are the number of heat wave days. So during that we are just looking at this. So if we see this is the IMD, then blue is 95th, then 90, and then 85. So you can see that 85th is very far away from IMD definition. Then 90 is somewhat closer to it, and if we talk about 95th, it is more closer to it. It means 95th percentile and IMD definitions are giving similar results, so we can go along with the 95th rather than 85th or 90th percentile. Because if you take 85th or 80 or 90 percentile, it will show more number of heat wave events, which is practically, it will not look like in practical things. So better to go with the 95th percentile rather than 90 or 85th percentile itself. So I have declared here that we have focus on 95th percentile and IMD because they are aligning more with each other itself, because they are having matching results across each others. So these are some of the results related to identification of heat wave using the IMD data set. So in this we have discussed some of these things, like Gwalior is recording number of recorded the most heat waves events, that is 68 events across this, and Jabalpur and Sagar is experiencing the longest heat waves around 11 days or 12 days. It means 12 days continuously heat wave is there, so it is very difficult that we can go outside in such difficult conditions. So mostly Jabalpur and Sagar is experiencing these things. Even if we talk about the duration itself, Sagar is recording the highest duration, followed by this Satna and Gwalior, and they have highest average duration also. Because we, for example, if a city is having experiencing 10 events, so we have taken the average duration of heat waves, and we found that Sagar is facing the highest average duration per heat wave event, with Satna and Gwalior is following the similar trends. So we can say Sagar, Satna and Gwalior are more vulnerable to the heat wave events. If we talk about severe heat wave, the most severe heat waves are also observed in Satna as compared to different other cities. Even Bhopal, Indore and Ujjain are not facing the severe heat wave condition. However, Jabalpur, Gwalior, Sagar and Satna, they are facing the extreme severe heat waves condition also. And I told you earlier also what is severe and normal heat wave conditions. These are the results related to heat wave according to 95th percentile, and these are also showing the similar results, that Gwalior or like Satna, Jabalpur, they are facing the same issue, and Gwalior had the highest average duration of heat wave across different one followed by the Satna and Indore, and these are having the highest average is 3.75 days. So in the next coming few slides we will discuss the heat thermal stresses or heat stresses across different things. So you just remember these things, whatever the value we will discuss, based on that we need to know what is the degree of discomfort. So we will discuss the value of different thermal indices. So these results are plotted only for a reason, that if we average these results, the value are ranging in between these. So you will say, sir, these are the value which we are you are showing in the plot is not having high thermal stress. So what is the effect of heat wave in Madhya Pradesh? So we have not taken the average only. This is the average. So you can see it is not going above 40. So thermal stress, high thermal stress, or we can say high discomfort will not be there if we taking the average of that. But during the heat wave event, some you can see it is going above 40 in all the cities of Madhya Pradesh. It means we have high discomfort condition. So I have just shown, I will show through these results. You can see that here we have shown all the degree of discomfort, like whatever we have classification for humidity index, some discomfort, no discomfort, great discomfort and dangerous conditions. So we have shown here for the Bhopal only from 1980 to 2024, and we see the combined effect of temperature on human humidity on human discomfort. So you can see from the figure itself, and you can have the classification here. So what we know that if we look at the figure itself, dangerous heat stroke possible days have increased from 120, which is in 1980 to 1990, to 180 in the last decade itself. So this is the most dangerous heat stress for us, and it is rising from 1980 to 2013 itself. These are not changing too much, but these dangerous conditions are increasing decade by decade itself. So this is the result for this. And if we talk about the no discomfort condition, it means the last some of the discomfort, it is dropping. This one is decreasing, but this one, which is most dangerous for us, it is increasing decade by decade itself. Then we are talking about the UTCI, and UTCI also shows similar result, that it is this UTCI, I already told that it will include the temperature, humidity, wind and radiation effects on the human body, because it have more number of parameters as compared to humidity index. So in this graph we see that heat stress in Bhopal has intensified over the time, with no thermal stress days decreasing and moderate heat stress reaching its peak from 2013 to 2024 itself. You can see the moderate one, that is this one. You can see this is continuously increasing from 1980 to this one. And if we talk about the no thermal stress, it means the no thermal stress is not changing. It is not even decreasing itself, what we are expecting, because due to temperature condition we can't expect that this will decrease, but we are trying to hope that it should decrease. But this moderate heat stress condition are increasing day by day or on a decadal basis itself. So this is a very alarming situation for us, that the heat stress across all the cities of the Madhya Pradesh is continuously increasing on a decadal basis rather than decreasing pattern. So these are some of the conclusions regarding this. If in a very layman terms I will say, the discomfort is majorly observed in this time period across different cities of Madhya Pradesh, that is 12 to 3 p.m. and I think you can feel that. And if we talk about, this is the highest one, if we go for the strong heat stress itself, it is ranging from 9 a.m. to 6 p.m. and I think we can feel right now that after 9 we need some cooling apparatus. Either we need to on the AC or a cooler. Without that we can't stay in normal fan or normal condition after 9. So this is the time where we need to have cooling condition, and for all the cities of Madhya Pradesh we are getting the heat stress from 9 a.m. to 6 p.m. and the most dangerous condition is occurring across these 3 hours, that is 12 to 3 p.m. itself. And we have also calculated the timing also, that how discomfort will be ranging from different period itself. So mostly some discomfort is there, great discomfort, then strong heat stress and very strong heat stress itself. And mostly these more thermal stress are observed during the heat waves rather than non-heat wave conditions, and heat stress intensity significantly increasing during the heat waves rather than non-heat wave events. So if we conclude about this study, so heat stress is highest at the midday, that is 12 p.m. due to direct solar radiation and peak temperature condition. And if we talk about the humidity also play a big role whenever we talk about the heat wave condition itself. You can also think about some of the cities which have high humidity like Chennai itself. So due to humidity reduces the body ability to cool down through sweating itself, due to which it increases the temperature and risk of heat related illness. So high humidity shows a greater probability of heat stress, because if humidity is less, our body will cool down very quickly due to sweating process. So due to humidity itself, our body will not able to cool down due to sweating, due to which the temperature condition or heat stress condition arises more. Next, we can conclude that during the non-heat wave periods, there is still significant risk of heat stress due to persistently high temperature condition, because we will not say that only during the heat wave conditions there is a heat stress. Because for example right now we are not facing the heat wave, but we are facing the high temperature condition, so it is also causing heat stress to us. So both periods we have to mention, whether heat wave or non-heat wave period also, both are important during the high temperature condition. And the major reasons to cause heat wave across Indian cities is due to urban heat island effect. Because in cities we have high population density, concrete infrastructure and limited green spaces in the country or in the cities itself, due to which it traps high heat for the extended periods, which creates high temperature condition across Indian cities or cities itself. And this heat stress intensity and discomfort level vary significantly across city due to temperature, humidity and local climatic factors. Means these heat waves depends upon various factors, not only the temperature, also about the humidity across that part, and along with that local climatic factors which are also playing the crucial role to define the heat wave. So these are some of the conclusions which can be helpful for the policymakers to develop the effective prevention and mitigation measures against the heat waves across Madhya Pradesh. These are some processes that drives the heat waves, so that we can get a better idea about the heat waves rather than taking only temperature as an input variable. Second, some of AI and ML techniques can also be used so that they give better results regarding this, and they can help in the better projection of heat wave across your study area. And based on that, we can develop city-specific mitigation measures, such as we can suggest green infrastructure and some cooling techniques across Indian cities or Madhya Pradesh cities. Thank you. I think we have Professor Lixin Wang here, so we will start his lecture after 2 minutes. Yes, because in this we have not taken humidity, because humidity also plays a great role in the heat wave itself. Because in absence of humidity, you can see, I think when someone has visited Chennai or Calicut, you can feel that even in the less temperature condition, we are getting more panic in the high temperature condition rather than here, because we don't have humidity feel. Like in Delhi, you have high temperature condition, high heat stress condition, but lack of humidity, it will help you out to cool down very quickly as compared to Calicut or Chennai. So that humidity should also be taken into the consideration whenever you are calculating the heat wave. For example, the same formula you are using for the Chennai or Calicut and the same formula you are using for Delhi. So it may have some disadvantage, because there humidity is playing some role. In Delhi we don't have that. Right. Right. For example, if you are taking the coastal area also, where wind speed is high, for example. So if you are not considering the wind speed also, that can also affect something, because wind speed can help you out in the high temperature condition also. So humidity, wind speed and temperature, all these means local climatic factors are important. You cannot say, so this is a universal formula you can apply any place. Some places are coastal, some are like hilly areas. So hilly area have different climatic parameters. So you can take the wind as an input parameter, you can take humidity as an input parameter, or you can take temperature along with that other local climatic factors for that particular area. Because same condition is not persist for the Goa. If you compare the Bhopal with the Goa, or like Visakhapatnam, you can say. So that is having different climatic parameters across Visakhapatnam as compared to Bhopal. So you have to make the changes accordingly. But since these 7 cities are very near to them, so need not to make much more changes. But if you are taking different parts of the country or different parts across the globe, you have to consider this.
Is there any elevation-wise variation among these 7 cities?
A deviation?
Elevation-wise
Variations in the definition? That we can consider. Means more number of input parameters we will take, obviously the accuracy will increase. For example, if we talk about any of the extreme event, for example flood or drought, you are taking precipitation as an input variable, you can say this is a meteorological drought. If you include SPEI for the meteorological drought, it will include more parameters, so it will give more accurate definition. Similarly, if you include the third or fourth parameter, I think it will give better result as compared to SPI. So more number of input parameter, obviously it will help you. Anyone else? Sorry.